All right, the end of semester 1 is near. We are going to be taking a look today, at the first half of our multiple choice final exam review. Again, you don't have choices, but when it gets to the final, you will. So we're going to look at the first half today, 1 through 25. Take care of the other half, 26 through 50, our next time together. So these first ones, I'm going to be honest, should be fairly simple for you to deal with. So I'm not going to talk a whole lot on these. Just kind of let my actions speak for me here. Got a little distributing to do. Again, be careful with your signs. Get all of your x terms to one side. I'm going to choose to add 4x to both sides. If you like your x's to be on your left, subtracting 2x would be fine. Isolate my x term, so add the 14 over. And divide by 6. Now, a couple things to make you aware of here. First, when you have multiple choice on the final, they will not be in decimals. Okay. Second of all, they will be in reduced fractional form. So if you get an answer, you're like, man, I think I did everything right. Check to make sure if you reduced it completely, because if you didn't, well, that could be one of your issues. Okay, number 2, biggest issue here, people forget these have parentheses. Because I'm distributing the 2 to the x and the minus 3. I'm distributing the 3 to the x and the 4. And basically then it looks just like number 1 did. So once I get that part out of the way, again, it's about details and just making sure I don't do something silly. Get all my x's to one side. And do my opposite to get the x by itself. Okay, so nothing too bad going on as far as that goes. Then we start throwing a few things in to make you think. Number 3. Biggest thing about number 3. M cannot be part of your answer. Okay, let me repeat that. When you solve for M, M cannot be part of your answer. So, first thing to look at. What do these two terms have in common? They both have an M. So I'm going to take the M out. And what do I multiply M to get M? 1. I can't just leave that blank. Okay, I got to hold the place. M to get a negative MC would be a negative C. And you see that I eliminated my problem. I now only have one M term. And since I'm multiplying it by 1 minus C, I now can do my division and get my M alone. Okay? Gotta look for those common factors. Gotta look. Number 4, rental car company charges a daily rental fee of $49 plus 75 cents for each mile, which means the variable will be going with it. Write an equation that describes the relation between miles and cost in dollars. Okay, so it costs me $49 whether I drive 1 mile, 100, 500 miles, whatever. But the number of miles I drive makes a difference, and that's what determines my cost. Do not put the C with the 49. Okay, the cost is the total amount that we pay, so it has to be on the other side of our equation. Okay. Breezing along here pretty decent, right? All right. Number 5, if I ever get down here we go. Okay, solve. Before I split, because again, absolute values I always have to split, we need to isolate our absolute value. Do not split before or you will make one of your answers incorrect. Oops, gotta remember my bars though. So once you get it isolated, now we're splitting it into 2 pieces. One of which is 2x minus 6 equals 8, just drop the bars. The second one is 2x minus 6 equals negative 8. Gotta remember the negative sign. Now I just solve each one individually and I've got my 2 solutions. So isolate my 2x. Get my first. Be careful, isolate your second, and get the other answer. Your answer won't necessarily just be plus minus the same number, so you really have to go through, take your time, and do the algebra on each of these if you want to find that success. Now we're going to kind of use number 5 as our example and number 6. Okay, we're going to be doing interval notation. But again, there's going to be 2 separate inequalities that I'm working with here. First one, leave alone, just like I did up in number 5. Second one, 2 things are going to change. My arrow is going to flip and the sign changes. So 1 extra piece from when we were just dealing with the absolute value equation. So again, I'm going to solve for each of these. Add my 8 over. Now, I have 1 or 2 suggestions to help you with the interval notation part. And this is not interval notation. Okay? 1 or 2 things. Either you recognize, because the absolute value is less than, that this happens to be an AND statement, the ones that we have the 2 endpoints and color in between. If I recognize that right away, besides the fact that's -10, somebody's probably already said that by now, at least I hope, and knowing that I go left to right, I would be able to look at this right now and just say, oh, -10 to 26. There's my answer, if I recognize that. But what if I don't? All is not lost. I could always make a quick graph and go, okay, x is less than, which is left, or equal to, a bracket, 26. X is greater than, going to the right, or equal to, bracket, at -10. And then I'd have a picture to look at. Left to right, -10 to 26. And I'd have the answer that way as well. So a lot of connections here when I give myself the opportunity to make them. And again, you'll have multiple choice, so it'll help you a little bit in trying to think through that. Okay. Evaluate at f of -2. In other words, when x is -2, what's the value? Look at your 2 quantities over here. Which one would x equal -2 work for? Is -2 less than 3? Yes, it is. -2 is less than 3. So I'm going to plug it into this top one. Because it'll only work in one, it won't work in them both. So you've got to make sure you pick according to the inequality. And that would be my value at f of -2. In other words, I plug in -2, that's the value I'm going to get out. Not too bad so far. Okay, let's see what else we got here. Oh, factoring. Okay, so when we factor, first we always look to see if there's anything in common. If we see that, great. Here, what I notice right away is they're both perfect squares. What do I square to get 9? 3. What do I square to get 64? 8. And then my form for difference is just those values in parentheses. And since I'm looking for a negative product, 1 plus 1 minus. And I'm good. Now, sometimes something can be a little trickier in disguise. Because you look at 9 and you're like, hey, it's the same as 8. No, it really isn't. Well, why not? 36 and 4 are both perfect squares. That's true, but there's one big difference this time. This has an x. There's another big difference. These 2 terms have something in common that divides into both of them. Both are divisible by 4. Both I can take an x out. Biggest number that divides in, smallest exponent. What's left over then? 4 times 9 is 36. X times x is x squared. And 4x times -1 is -4x, to which the second issue that people have comes up. I'll have people then that want to break this down and do 3x plus 1, 3x minus 1, but there's one dilemma. There's no quadratic here. If there's no quadratic, I can't factor anymore. Be careful, I'm sneaky. Just saying. More craziness. State the domain of the function. Before you write -infinity to infinity, look, are there arrows? No. Ends here. Ends here. What's domain? X. Left to right. -4 to 4. careful. Be careful. 11. Describe how the graph of the function is related to the graph. In other words, what are the shifts? What are the transformations? What does the -3 and the 4 mean? Remember, what's inside the absolute value is my left and right. What's outside is my up and down. But what's inside is always the opposite of what you would think. And what's on the outside goes along with what it normally would. So, normally I'd think of negative as left, but it isn't. As I say, it's we think of it as left, and I write left. No, Harty. Right 3 and up 4. Ay. So I got to be careful on that a little bit, I guess. Name the vertex of the following. Remember, when we're in absolute value equation mode, my vertex is at HK. The only real thing I got to watch out for here is that it's opposite of H and K in here. So the opposite of 2 is -2. But I keep the sign on what's outside. That's what the plus means. I get my vertex. So opposite of inside, keep it on the outside. Rolling. We're almost halfway through this first bunch. Write 10 to the 2/3 in radical form. Always remember, exponent, root. Just like in the alphabet, E comes before R. So, 10, my exponent is 2. My radical, or root, is 3. Now, this could be written this way, or 10 squared may actually be written out as its value. Either of those would be correct, so you have to be prepared to do either one. For 14 and 15, we know our exponent rules. When we multiply, we add. When we divide, we subtract, but we need a common denominator. Now, for some of you, here's our options. If you're good at finding your common denominators, 4 and 5 would get me 20. 4 times what gets me to 20? 5. So 5 times 1 is 5. 5 times what gets me to 20? 4. So 4 times 3 is 12. And I can get my answer. Now, let's say that's not a strength of yours. You're like, Harty, you just did that. And I'm like, I still can't even figure out where you got the 20 from. Okay. So here's our other option. Take the two fractions. Now 35, though, that would not help me. There. Math enter, 17 over 20. As long as you remember it's plus, you have that backup plan. Same thing with the next part. Again, we're subtracting exponents. Once again, I would be looking for a common denominator, which would be 40. 8 times 5 gets me to 40. So 5 times 7 is 35. 5 times 8 is 40. 2 times 8 is 16. And just like we did on the last one, if I just want to take my 7/8 minus my 2/5 and math enter, there's my 19 over 40. Oops, see a little better up there. So again, you have options. Okay, a lot of this is just, have you gotten enough practice to feel comfortable with it? If you haven't, that's where it might start biting you in the butt. All right, solve. Need to get to x, radical's in the way. Opposite of square root is to square both sides, even the side without the radical. That's the part that people tend to mess up the most here. Well, besides the factor that, and they say 11 squared is 22. That doesn't work out real well either. Add my 9 over. Now this is normally where somebody is thinking, hey, I thought there'd be 2 answers for this. Because I see the squared, to which I say, okay, but my original problem doesn't have a squared term. My original problem is a radical. There's going to be one answer. If I have a squared to start, that's when I'm going to have multiple answers. And again, when you get here, if there was a decimal, you could get to it. If it was a mixed number, you could get to it. But again, more times than not, we're just going to have the fraction there for you as your solution. Okay? All right. 17, again, don't get sucked in to thinking you have to slide and divide. Use the golden rule. Take the 2 out that they all have in common. It's going to make your life easier. Because now it's just a diamond problem where I'm multiplying and adding. Multiplying to get a negative, one of each sign. I'm adding to get a negative, means the negative number is bigger. So I'm looking for 2 numbers that multiply to 12 that are 1 apart. Sounds like 4 and 3 to me. Then whatever term has an x gets set equal to 0. 2 does not have an x with it. I can't set it equal to 0. If it would have been 2x, then I need to. Keep that in mind. But in this case, that's not the case. So I can go ahead and just get those values taken care of, put together. No biggie there. Okay, so again, it's a lot of stuff, but again, with having some choices there, that's going to help. And also, kind of mess with that a little bit. Okay, quadratic formula in our brains. So we get that in there. Again, just details. Opposite of b, which would be positive 3. B squared, the negative in parentheses. And this is not where we want decimals. So I could punch this part into the calculator. Now again, I don't want the decimals. So if I'm going to do that part, notice I'm typing it in. I'm not using the square root. I just want to know what that comes out to. It comes out to negative 63. But I know I can break down negative 63. 9 and 7. I also know I need to pull an eye out. Yeah, people broke my eye. What's up with that? So 3 plus or minus 3 square root of 7 over 4. Exact answers unless it's an application. Just saying. All right. Solve using square roots. Isolate your x term. Even if it's a perfect square in front, don't do the square root until it's isolated. And now for those of you that were thinking earlier, should have been 2 answers. Now you're right. It's squared. There's 2 answers. It's a quadratic. But if you can break the radical down, you need to do it. And again, one of the 2 values has to be a perfect square. Otherwise, it's kind of useless. And I get to my solution. So again, it's just kind of piling your way through, not doing silly stuff. Like on 20, not thinking you should distribute the 2. Bad idea. We want to isolate our parentheses. Now I'm still trying to get to x, but I can't get to it yet because the squared's in the way. Square root, but it's still a quadratic. Plus minus. I just noticed something. Somebody probably noticed this already, but I'll go back to it in a second. I'll keep you hanging for a second. Okay, 24, 4 and 6. Now somebody may be thinking again here. I'm trying to think like you guys as I do this. Well, couldn't I use 2 and 12? No, because 2 and 12 aren't perfect squares. One of them needs to be able to break down nice. The other one, not so much. And then I can add my 3 over on this side of the plus minus. But again, if nobody has noticed yet, kind of makes me feel bad. So hopefully they did, but I'm going to go back and talk about it now, even if we already did it in class. Back to 18 for a second. I was breaking down the square root of negative 63. And it just goes to show, I just did it. I can see how you could do it too. What happens when we have the negative? I showed the I. Did I actually take out the I? No, I just talked about it. I didn't do it. How's that consistent with some things that get done in class? Okay? Got to remember that I. So see, I make the boo-boos too. All right, speaking of I. Oh, it's I redemption. Here we go. See a negative? I'm going to pull the I out. Do it right away this time so I don't forget. 144. You should know this. Square root of 144 is 12. Is it plus minus? No, it's not a quadratic, so no plus minus. Okay. Same thing working here. I'm just going to keep pulling the I out right away so I don't forget it. All right, so 6. Okay, I know that part. Remember, here, my little root number is 2, and this is where we do the division thing. 2 goes into 3 how many times? Once. How many do I have left over? 1. Just simple, long division. However many times it goes in. Remainder inside. 2 goes into 6 3 times. I don't have any left over, so I'm good. Like, all right, I can kind of see where he's going with some of this. 23. Don't overthink it. I know, I'm just telling you before to be careful. Now I'm telling you not to overthink. There's a minus here, which just means we're going to distribute the negative and combine like terms. Don't box or FOIL. Standard form means we put our constant term first, our imaginary term second. But 24, notice there was a minus 4. Now there's nothing in between. Now we do have to box or FOIL. So it doesn't matter what you do. Either preference is fine. So first, outer, inner, last, with a reminder, what does I squared equal? -1, that's right. So this is really negative 54 times -1, or positive 54. So when I go to finish this up, 5 plus 54 is 59. 6i minus 45i. Oops, I got a little too quick there with my plus. And I'm good. Okay, last one for today. 25. All right, identify the relative minimum value of the function. Well, it'd probably be good if we looked at it first. So, x to the third minus 5x squared plus x plus 8. All right, so let's take a peek at what this looks like first. Okay, so identify the relative minimum value, where the valley is. If we were asked for a maximum, we'd be looking up here. We want the min. So second trace, we're looking for the minimum. Now, some of you may be asking, if I'm not comfortable with the calculator, is there a way around this? Yes, I will show that here in just a second. But since you're going to have calculators in here anyway, I think this is the best way to go. So I get my cursor down as close as I can to the minimum. 3 to the left, enter, there's my first border, 1, 2, 3, 4, 5, 6 to the right, there's my other border, I'm trapping in my min, and my min value, but notice, the relative minimum is the y value, okay, so it won't be coordinate points, it'll just be the y value that I'm looking for on that. So you're like, okay, well, what if I didn't, forgot how to use the calculator or something? What would you tell me that I should do. And there's not going to be a ton of other options for you, because some of you may be thinking, well, couldn't I just find the vertex? But this isn't a quadratic. Okay? So really, you do need to have your second trace function and kind of deal with that right now. And we'll take on the rest of this in our next video. So you're doing good. You're halfway there. If you have questions, let me know. And we'll see you on the other half.